confidence intervals, and now we're looking at hypothesis tests. So hypothesis tests are of the form hypothesis such as beta equals 0 versus beta unequals 0. This is called a two-sided hypothesis because either much larger or much smaller values of beta, of the estimated beta, here, this is the estimated beta, are evidence against the hypothesis. Generally, we're trying to see whether we can falsify the hypothesis, so we can reject it. So we don't accept the hypothesis, we reject it because there's evidence against the hypothesis, or we do not reject the hypothesis. So let's look at our evidence. It's a t-statistic. So it's the estimated value minus the hypothesized value, which is 0 in this case, divided by the estimated standard error. And that is t-distributed with the usual degrees of freedom, n minus 2. Now, in this case, our estimated beta is here. It's a fairly small value, but the standard error is even smaller. And this minus 0 divided by that is this t-statistic. And the probability that you get a value that is larger than 14.13 or smaller than minus 14.13 is very, very small. It's so small that in approximation this is 0. It's not equal 0, but it's very close to 0. So what this means is we reject the null hypothesis and we say there's evidence against beta being 0. Incidentally, the hypothesis corresponds to the 95% confidence interval correctly, exactly. If 0, the hypothesized value, is not inside of the 95% confidence interval, that means that you must reject the hypothesis at 5%, because it's the same kind of calculation. So in other words, that the p-value that results from that must be smaller than 5%. This is always true like that. And if you had a 99% confidence interval and 0 were outside of the 99% confidence interval, then the p-value would have to be smaller than 1%. Okay, so this was the usual null hypothesis where you test something being 0, the parameter being 0 versus not. And there's also the one side, the test for another value. So for example, we could ask ourselves, we could test, could beta be 0.01? So in that case, I do the same calculation. I just plug in a different value for the hypothesized beta. So here I have my beta hat, the hypothesized beta, the estimated standard error, and I get minus 19.7. We are only interested in the absolute value. So 19.7 is very large relative to 2 or 1.96. So we know this is going to get rejected. So it cannot be 0.01. And indeed, if you plug it into a computer or a calculator, the p-value turns out to be smaller than 0.001. So we reject the hypothesis that the slope could equal 0.01. That's the end of this current segment.